I'm sick of opening ads and seeing people complain the Next.js app router is painfully slow. Let me make this clear. Next.js is not slow. The framework itself is insanely fast. Problem is that a lot of folks are writing React as if it's 2019 and expecting the server to magically fix their terrible architecture. Now, I review a lot of code bases. Between my own students taking my Modern Full Stack Next.js course and from what I see in the community, a lot of folks are making the exact same mistakes over and over again. Shipping massive JavaScript bundles to the client, redundant network round trips, and opting out of key performance optimizations for literally no reason. So today, I'm going to show you the 5 things that make your Next.js apps painfully slow. And we are going to fix them right now. By the way, I see this so much that I've actually compiled a free cheat sheet of a lot of common Next.js mistakes and exactly how to fix them. You can download them completely for free using the link in the description below. So now, let's get into it. Now, before we change a single line of code, we need to know exactly what is making our app slow. Blindly guessing would just be a waste of time. So let's lean on some performance optimization tools that come out of the box inside of Next.js. The first optimization is to use a bundle analyzer. All we need to do is 2 things. If you're using TurboPack, then we could simply just use the bundle analyzer for TurboPack, which is simply this command. However, you need to be on v16.1 or later. But if you're not there yet, you could simply use this plugin for Webpack. You need to install the package, wrap this up in your next config, and this will generate the report as well. Since I am using TurboPack, let's just go ahead and use a specific command. So I'm going to copy this, head over to the terminal, and paste it. So now once we do, this is the report that it has generated for us, and this is literally the report. Now, Next.js will generate a visual interactive map of our compiled code. So you can see this giant block here. This is React DOM client. We need that because that's what runs our React DOM code. So that's again a heavy library that's being sent to the client that you probably didn't even realize existed. But we also need to know exactly where our enemy is so we could start shrinking our bundle, because this is one of the common mistakes that a lot of you make. So if we go to the page, you could also just navigate through all the different routes. And if we go to bundle analyzer, because that's the route that we are on, you could also see this package, which is datefns 16.98 kilobyte. Now, this is a date library which could easily be on the server side instead of it being on the client side. Now, the total size of our bundle is 317.30 kilobytes compressed. If we get rid of this library, that reduces the size of our bundle. Any page that needs interactivity needs to be a client component. In our case, we are simply just showing this specific card, which a bunch of different icons, and listing the date here from 3 days ago since last deploy. Now, we do need a date library for that. However, this page is a great candidate for it to be a server component. The minute a page is a server component, we just ship less JavaScript to the browser because now the server is handling it. So if you remove the use client directive, now the date library and the functions that we are accessing from here are no longer going to be part of our bundle. So let's run a build again. For that, we have to run run build. This will create a optimized production build. Let's run Bottlenecks next experimental analyze. It's no longer 314, but instead it's in fact 304 kilobytes. So our bundle has drastically reduced. And datefns has also disappeared from our bundle because we are no longer using it, because this is exactly what gets shipped to the browser. So I highly recommend you to analyze this specific bundle that gets shipped to the browser, because there might be surprises, things you may not be aware of, and you could easily optimize it. Now, the absolute biggest mistake I see, and I mean I see this everywhere, is what I call the use client virus. By default, all components inside of Next.js app router are server components. This is a superpower because JavaScript for these components never gets sent to the browser. But developers get lazy. They just need a single interactive button or a toggle, and they just slap a use client directive up of the root page component, and when you do that, it infacts the entire tree. That page and every single child component inside of it now ships its JavaScript to the browser, and you lose all the performance benefits instantly. In this case, we have these 2 blog post cards. It doesn't have a like button, but this is what developers do. This is the page for it. We have this array with 2 blog posts, and then we are looping through that over here in this page. But let's say now we want to add a like button to the specific blog post. So we need a button functionality. So let's add the button. Let's store it in a state, and let's also import it from useState and import the heart icon from lucid React. Now everything else stays the same. So now we get an error saying that you're importing a component that needs useState. This React hook only works in a client component. To fix this, mark the file with the use client directive, and developers go, okay, I'm going to do that. I'm going to do exactly what you just told me. Because developers get lazy without thinking that now this entire page will get shipped to the browser. So our bundle size is going to go up. But if you take a look, they're just going to slap a use client directive here, head back, refresh the page. Now we have a like button here, and we have this nice interactive here as well. It's a bad practice. What we need to do instead, the fix for it, is to push this specific use client directive as far down the component tree as possible in the leaf nodes. Extract that interactive button on its own leaf node, because none of the other content in this page needs a client, that is our browser. The only interactivity we have is here. So let's do that. Let's remove the use client directive. Let's move whatever we need inside the state and the specific interactivity and extract that in a like button. And the like button has literally the code that we extracted out. We also need to remove the unnecessary imports, and this doesn't need to be a use client directive anymore because we have extracted that out in a like button. So the minute we do, it still works and our interactivity works as well, which is exactly what we're looking for. And keep the layout, the text, and the data fetching on the server where they belong. Whenever we need interactivity, let's extract that out only into its client component and not just believe every single error and the fix that it's suggesting as well. All right, your bundle is smaller, which is awesome, but your server response time is still slow. Why? Because we're accidentally creating data waterfalls. Here's what I mean. You have this course platform with a couple of feature courses, 3 different courses, which are basically all the courses. And then we have 2 instructors here and a bunch of recent reviews. Now, this essentially means that we have multiple await calls in our server component. So if we refresh the page, watch what happens. We are going to get all the data at once. But this specific featured course might be a faster database call compared to all courses. Then why are we creating these accidental data waterfalls? If you take a look at the code, here's what happens. You're getting the courses, you're getting the featured courses, you're getting the instructors, and getting the reviews. This one takes 1.5 seconds, 1.5, 1.2, 1 second, and the total adds up to 5.2 seconds. Now that's a lot. That's a long time. Reviews is ready in 1 second, then why shouldn't we wait for the others that might take longer? If the data is ready, it should simply just return that data. So since we have multiple await calls in our server component, because we don't have a use client directive here, this specific second fetch will not start until the first one finishes. None of these depend on each other at all. So if they don't depend on each other, we could simply wrap them up in Promise.all. This specific approach fetches the data in parallel and instantly cuts your load time in half, because now we don't have to wait for one API call for the other. It's a big mistake that developers make, and it's a simple fix for it. At the bottom of the course content, we have the suspense boundary. And we are rendering the course content. What we essentially need to do is extract this out in its own components. What you do here is just take a look at this specific page. We need to split up our async calls. For example, we need to get courses in this specific component, all courses here, instructors here, reviews over here, and then in the final page, we could just simply add a suspense boundary to each one. Now, the other option we could also do is, instead of splitting them up individually, we could also just use Promise.all, which runs all of them in parallel instead of sequentially. But again, still data is available to you right away. You cannot take advantage of streaming. So by using this specific approach, wherein you are moving the data fetching close to the component that needs it, is very helpful. And then by adding suspense boundaries, you just simply don't need to do it. If you can already see this data is available, then this gets available, and these two almost at the same time. So this is a massive mistake a lot of developers make. So make sure that you use a combination of these techniques to take advantage of it. Now, things get worse. A massive mistake developers make is fetching the exact same data twice. And this one is a really sneaky one, but I want you to be aware of and make that change right away in your code bases if you haven't already. You often need to fetch data for SEO reasons, as well as to render that same data on the page. You often need to fetch a product. In this case, the product is this specific course, Modern Full Stack Next.js course, for your SEO data. So I could easily update the title here to be the title of this specific course, update the description, just for SEO reasons as well. However, once this page renders, you also need that exact same product over here on the page to display it to your user. So now if you take a look at our terminal logs, we are calling product 1 during the pre-render phase for SEO metadata, but also we are calling that product again on the server because your page also needs it. So this means that you will see your database is getting hit twice for the exact same request. So we definitely need to prevent that. To fix this, we could easily do a few things. This is the journey metadata function that gets the product. This is the first database hit. This is what sets the title and description. But the actual page itself also meets that exact same call, the get product call. And we display it onto the page. Just wrap it in a React cache function or use the Next.js use cache directive. Now, Next.js will memorize that request. You can call that exact same function 50 times in your component tree, but it will only execute the database query once. And it is a massive performance saver. So let's do that. If we go here, let's add a use cache directive over here. Now, let's open up our terminal one more time. Let's close this. Let's refresh the server. And there we go. Now, this console log, in fact, comes from the cache. It's no longer fetching it twice and it's coming directly from the cache, which is exactly what we want. And this itself is going to be a massive time saver. In my course platform, there are thousands of students, and I don't want to be making the same database call over and over again, or in this case, 2 times the thousands of students. That's a lot of database calls, and I really don't want to do that. Now I have literally saved a lot of time by caching that specific code. By the way, if you're tired of piecing together random tutorials and want to master these concepts end to end, then check out my Modern Full Stack Next.js course. We build and deploy 7 production-ready applications from scratch, covering advanced caching, authentication, error logging, and all the performance best practices that I cover in this specific video and beyond. So the link is in the description, and there is a surprise waiting for you if you download the specific cheat sheet. Now let's talk about spinners. Now here's a hidden performance drain that even senior engineers fall for. You want to show a loading spinner while your data fetches. So what do? You turn your perfectly fast server component into a client component just so you can use a use state from React with a loading flag and a use effect to update the state, the loading to be true, the minute the data fetching passes. Now stop doing this. You're shipping React state and client-side rendering code just for a simple spinner. Instead, delete all of that client code and keep your page a pure server component. So if you refresh the page here, we want to show this beautiful skeleton. But in order to show that skeleton, we need to lean on browser interactivity, but we don't really need to do that. Here's how. So we have this page wherein we have a state for storing the posts. We have a loading spinner here. We fetch the data, and then we set the data and then set the loading to be true. Set the loading to be false. By default, it is true. Now, we show a skeleton here for when loading is true. Otherwise, we show the post. This is a very common code that you are going to see everywhere. So what we can do here is turn this into a server component and completely not use the use state. Let me show you. So let's remove the state altogether. Turn this from a client component to a server component. We don't need any of this, right? And we also don't need any of the loading state here as well. Well, then you're wondering, how do we get the data? We could simply just get the data by marking this specific page in the async component and getting the post from the lib, which is what we had earlier. We could also remove the skeleton and any unused imports as well. But in order to show the loading spinner, what we can do is go here and create a file called as loading.tsx. Now, I already have this specific file ready for us, so let's just copy this and paste it over here. And now in this case, by simply creating a file called as loading.tsx in the same directory as our page, Next.js essentially uses React Suspense under the hood to automatically show this specific loading UI while your server component resolves. It requires 0 client-side extra JavaScript and keeps your app insanely fast. So now if we go here and refresh the page, we still see the data. But as you can see, if we refresh the page, we call it blog post and then we switch it to loading trap. Well, let's just replace loading to be loading trap here. And now if we head back, it's just an instant skeleton change with no text or layout shifts whatsoever. Instead of turning it into a client component just for a loading spinner, leverage loading.tsx instead. So now your entire page is not client rendered, it's on the server side. So we are shipping less JavaScript to the browser, thus giving you performance gains. Now finally, we have to fix what the user actually sees. The web is full of images. So if you don't optimize your images, your app is going to suffer. If you have a largest contentful paint that is LCP and that is slow, It's usually because you have an image there. You could simply use the browser image tag, which is great, but Next.js also gives you an image component out of the box that you could also leverage. That specific image component wraps the browser image element but gives you additional performance optimizations. For example, if we go back here, that's how we are displaying the image. We have an image for Modern Full Stack Next.js course over here, but instead of using the image tag, we could simply replace it with next image that comes from next image. But forget to pass the sizes prop, you're making a massive mistake. Without the sizes prop, you might be forcing a mobile user to download on their 3G connection to download a 1200 pixel desktop image. We don't want to do that. If they are on mobile device, they should download a smaller image. And that's exactly what the sizes prop allows us to do. So we could just do sizes prop, and this will serve a perfectly sized image for their specific device. If you refresh the page, you're going to see this specific image, which is 74.3 kilobyte image. Now, if we go to the responsive mode and go to a mobile device, and let's stop it and refresh the page again, the same image is 13.5 kilobyte now. And that's thanks to the sizes prop. We did not necessarily download a massive image if the user's device is smaller. So that is very, very important. And lastly, alongside images, it's the layout shift. You just need to stop importing Google fonts manually and start using the Next font package. What happens is the minute you manually add fonts inside your CSS file, it blocks the rendering and makes your text jump, giving you that layout shift around on load. We could simply use the Next font package from Next.js. It automatically pre-shakes the font. That means only the font that you import will be included in your browser bundle, and it will preload it and host it locally, so 0 network requests to Google and 0 layout shifts, which is very important. In here, we are using the Inter font, but because we've used it directly from Next font Google, there are 0 layout shifts. This specific font is hosted locally in our package, and as a result, we get additional performance benefits, because if you use a lot of fonts, it can really add up. If you measure your JavaScript bundle, push your client components down the tray, use several performance optimization mistakes that I have talked about, such as memoizing your database queries, the next app essentially will go from sluggish to lightning fast, because Next.js has so many of these little gotchas, and I put together a handy cheat sheet, a completely free handbook documenting a lot of these Next.js mistakes and exactly how to fix them. You can use it as a checklist before you create your next pull request, or add it as a skill in your project. And if you're ready to take on skills to the next level, don't forget to check out the Modern Full Stack Next.js course as well. If this video helped speed up your app, let me know in the comment below. Is there something new you learned in this video? And if you want me to create similar content just like this one. Alright, hit that like button, subscribe to my channel, and I'll see you in the next one. Bye for now.